But you can see there is a natural rubber chains. So there are 3 chains. Whoop, come on. Okay. And you add sulfur and vulcanization accelerator. Have you heard of a vulcanized rubber before? Yeah. So start with liquidy thing because it's tree sap, so it comes out as liquid from tree, right? You collect that. Okay. They have got chains, but chains are not associated. Chains are not connected. And by introducing sulfur and other agent, you can make cross links between. So you can see disulfur links, yeah, between the chains now. What that means is that the liquid, they were just viscous but still liquid, is now appearing as solid, okay? Because cross links are there and the chains are somewhat fixed to one place, okay? Of course, if you put more sulfur and if you put more links of the cross links between the chains, you will have even more rigid ones, okay? Think of rubber. You can start from natural rubber that was liquid, and by putting a bit of sulfur into it, you can make into rubber band. What other materials do we have that uses rubber? Tires, good. And tire is a good example of heavy vulcanized rubber. Okay, you don't want this to be used for your car wheels, right? You want something rigid, something that can withstand heat, sometimes coldness as well. Yeah, so that would have a lot more sulfur in it. Yeah.
Like a rubber mallet. Is that like similar to like that?
I would say so. Yeah. I would say they would have. Yeah. Otherwise, yeah. You don't want to be hitting something with something that's flimsy or soft. Yeah, that would just bounce back, wouldn't it? Rubber mallet, yeah, definitely. So vulcanization is a process that's there. Problem with this, well, in many Asian countries or third world countries, I should say, is that the only place where tires can go is the yard where they just light up and then burn it. What's in here? Sulfur. And when you burn sulfur, what happens? Sulfur dioxide, and sulfur dioxide becomes sulfur trioxide, and when it touches water in the air, sulfuric acid. Yeah. Yeah, so all the carbons will be burnt off, as well as it will probably even cause acid rain due to sulfuric acid. Disulfur crosslinks. Oh, chewing gum. Let's see if we can watch that. So yeah, that's from a I guess pulled back point of view. So polymers become close-linked, and it become like that. All the lines will be now connected. Let's just finish this off first, and then go back to the chewing gum video. Okay. Still talking about bonding between polymer chains. Now, so cross-linking was a proper link, okay, proper bonds using sulfur just then. You can also have dispersion forces, or I should say secondary interactions. Okay, dispersion forces is one of the things that would be already there. Non-polar polymers experience dispersion forces between the chains. Probably that's the reason why tree sap that comes out from rubber tree is very viscous, okay? Because those long chains are interacting with each other. The longer the chain, the greater the dispersion forces. Shouldn't be a new idea. Polymers with dispersion forces between the chains are soft, flexible, and non-elastic. They would have low melting point or boiling point, so they can be softened and reshaped, so are suitable for recycling. Okay. So the plastic materials which can be recycled, usually category 1, 2, 3, with a recycling logo. Yeah. those numbers actually represent different types of plastics. If I'm not mistaken, 5 is PVC. I forgot which one, but PVC has got a certain number, and that's a bit harder to recycle because the melting point is much higher. Categories 6 and 7, they are considered to be others. So new types of plastics or not large quantities created, and they are harder to also recycle. But number 1 to 3, they are fairly easy to recycle, okay? Because melting point and boiling points are lower. Now, hope this rings a bell. Okay, so Mr. Ryan Logan was talking about how polystyrene is what he's using, wasn't it? Yeah. So polystyrene and polyethylene, I don't know them. I forgot which one actually. Is what he uses because they are widely used and it's easy to get pure waste from other industries. Polyethylene, polypropylene, PE, polyethylene. PE is something that you might see on the label of stuff, and polypropylene is usually written as PP. Also, polyethylene PE can come in low density or high density. So LDPE or HDPE. They are the logos that you might also see on some plastic materials. If you have dispersion forces, you can also have hydrogen bonding. Now, this occurs between anywhere that can cause hydrogen bonding, like OH or NH groups within the chain. Carbonyl groups, CO double bond, they are also sites where hydrogen bonding can occur if there was a neighboring hydroxyl group or amine group. Okay, and that's what happens in DNA anyway to keep the shape. Hydrogen bonding results in a polymer with greater strength, rigidity, and elasticity. Cellulose and polyamides, they usually have hydrogen bonding. What that means is that that boiling point, melting point will be much higher compared to the ones that rely on dispersion force. Sorry. Last slide. Now, the two categories of plastic mainly. One is called thermoplastic. So, both Presimax factory and Advanced Plastic Recycling Company, those two deals with this type of plastic, thermoplastic. Okay. Thermo means heat, plastic means changeable, I think. So polymers with hydrogen bonds are dispersion forces between chains. If there is no cross-link covalent bonds, primary bonds that is, okay, it's easy enough for you to change its shapes. All right, so you can do injection molding, you can reshape it by heating up again. Yeah, as you saw at the factories. They soften when heated and return to their original condition. Of course, some sort of degrading occurs according to Don. If you keep using the same plastic, like what he can do is that when something come out in an imperfect shape, he can just crush it, make it to granule, and put it through the machine again. But if you keep doing that, the plastic would degrade and it loses its property. So he prefers not to. Yeah, that's why those wastage is usually sent to companies like Advanced Plastic Recycling instead, because they do different application. By using wood chip soda filler, they compensate the property. So, thermoplastics are good for recycling. Okay, thermosetting polymers, thermoset polymer, they are the opposite of it. Okay, polymers with a large amount of cross-linking, such as tires, yeah, or anything that's harder, something that can withstand heat, like plastic that's used for lights they're plastic, but they don't melt when you turn the light on. Or say handles for pots. You don't see them melting away that easily. Yeah. So they would have got cross-linking in there. Yeah. So there are some thermoset plastic. Okay. By having cross-linking, they do not soften or change shapes when heated. Instead, decompose. Okay. Consequently, they are not suitable for recycling. So it says decompose. What it means is that the long chain that originally plastics had, so polymer chain had, they'll start breaking into smaller parts. Okay. So thermoset plastics or those pots and pans handles, if you leave it long enough under UV ray, so if you give that to your child and then they'll start playing for like a long time under the sun, and if they leave it on the ground a long time, they'll start being flaky. So sorry, that was me. So the plastic will start changing color to like something powdery, and things will start coming off instead of melting down. Okay, so those little particles would come out. Again, not good for recycling. Okay, and that's the end of polymer parts.